Right then, nucleophilic substitution is the aim of the game today, so we're going to have a look at that. Nucleophilic substitution is something that you need to be able to define and recognise, and I'm going to give you a couple of examples of how it works and some examples of the reactions which will happen. So first of all, let's define it. Nucleophilic substitution is going to involve a nucleophile, and if you remember your definitions, then that means that a nucleophile is something which is attracted to an electron deficient centre, where it donates a pair of electrons to form a new covalent bond. Okay, so what we're going to do is take that nucleophile, we're going to put it into a substitution reaction. Okay, now a substitution reaction, if you remember your definitions, is where we take an atom or a group of atoms and we replace it with another different atom or group of atoms. So we're going to do nucleophilic substitution. We're going to take a nucleophile and we're going to substitute something on a molecule with something else. Let's have a look at how this works. You've got a molecule which needs to have a couple of features, and if you're trying to spot whether there's a nucleophilic substitution reaction going on, what you want to look for is you want to look for some kind of organic group. But because this nucleophile is going to be attracted to this is going to have to be electron deficient, so this is going to have a delta plus. And over here, this must therefore have a delta minus. Okay, so when you're looking and see, well, is this going to be a substitution reaction or not, you're really looking for something there which is very electronegative. It's something like a chlorine or a fluorine, a halogen of some description, something which is going to pull the electrons in this bond over here. So our nucleophile is going to be attracted to our electron deficient centre. How are we going to show that here? Well, we need our nucleophile here is going to have on it probably a minus charge, not always, but sometimes, but most of the time, and it's also going to have a lone pair of electrons. So we're showing an attraction of an electron to an electron deficient centre. So we're going to show this with curly arrow, which shows the movement of that pair of electrons attracting to that carbon atom. Okay, and what's going to happen then is it is going to donate a pair of electrons, which we're showing with that arrow, and then it's going to form a new covalent bond. Okay, so there is going to be a bond forming between this nucleophile and that carbon atom. So why is this going to substitute? Well, because carbon only forms four covalent bonds, and so one of these is going to have to break. Which one will break? Well, this is the polar bond. This one is going to be the one which breaks. The electrons are already pulled quite a long way towards this halogen on average, and so we're going to break this bond by heterolytic fission so that we lose whatever was on here. Now there's a couple of examples that you need to know for this, but I will show you in general what that means is that we end up with whatever we had as the organic group staying more or less the same, and then we have the nucleophile stuck on this carbon atom, and we end up with the whatever was on there leaving as probably some kind of negative ion. Okay, that's the general idea of what's going on here. Hydrolysis is an example of a nucleophilic substitution reaction. What we're going to do is we're going to identify, here's a molecule. Is it going to do nucleophilic substitution? Well, yes it is. Why? Because we've got a polar bond here. So we've got a delta plus there, and we've got a delta minus there. Okay, what's our nucleophile? Well, our nucleophile is an OH minus. How can we tell? Well, because the big clue is that it's negative. The other clue is that it has a lone pair here which can react. So what we're going to do is we're going to say, right, okay, well, this is our nucleophile. It's going to be attracted to the electron deficient centre, and therefore we're going to donate a pair of electrons and form a new covalent bonds there, and it's a substitution because simultaneously this chlorine is going to come off, and that will give us ethanol and a chloride ion.